Hello, hello. So, today, in theory, is Friday, May 17th. I'm recording this on May 9th, so I don't 100% sure know what day it is because things are up in the air a little bit. But today we are moving on to surface area of prisms and cylinders. Remember that your volume of pyramids and cones worksheet in theory is due today, so do not forget to get that turned in. We are on page 11 of our notes packets. So grab a calculator, grab your notes packet. So today we're talking about surface area. And surface area, by definition, is the amount of two-dimensional space that the faces, in other words, the sides, that a three-dimensional shape takes up. So the two-dimensional space taken up by all those faces. Now, when it comes to working with surface area talks about all the faces, all the sides of the shape added up. But there's also what's known as lateral area, which is important to know because when it comes to working with our shapes, there's the bases, and then there's the lateral faces. So lateral area is the area of those non-base sides. Now that can be important because at times you are going to be given information in reference to the lateral faces. So there's actually multiple formulas for surface area of most of these shapes, actually of all these shapes technically. One of which we'll use a lot more often, but I will give you both formulas as we go through. So today we're talking about prisms and cylinders. Focusing in first on our prisms. Remember that a prism is a two-dimensional shape in which there are a pair of opposite sides, both parallel and congruent. They come in lots of different forms. The basic formula that they use is the fact that when it comes to a prism, there are two bases. So it's 2, and then the base area plus the lateral area. Notice that they are capital letters because they are things you have to calculate. It's not just a base like a length, it's a base area and lateral area. This is the formula we don't use quite as often because generally we don't have lateral area just given to us. So the more common one that we use is 2 times the base area plus the perimeter of the base times the altitude of the prism, times the height of the prism. So P is perimeter of base. H is height of prism. Now you got to keep in mind that the height of a prism is always perpendicular to the base of the prism. Much like when working with our two-dimensional shapes. So when it comes to working with these various shapes, one of the things that's important is recognizing what shape it is in order to know what formulas you need to use. So much like you've seen me do before, the first thing I'm going to ask you is, what is the name of the shape? This first one here, the sides that are both parallel and congruent appear to be these triangles that are hanging out here. So those are my bases. Since the base is a triangle, and there's 2 of them that are parallel and congruent, it's a triangular prism. So, being triangular tells me that base area is 1/2 base of triangle times height of triangle. And being a prism, and I'm looking for surface area, that tells me that the surface area is 2 times capital B plus the perimeter times the H. Keep in mind, that when it comes to this, that H and that H are not the same. The first H is the height of the triangle. The second H is the height of the prism. Now, when it comes to these, I often pull that base off first, kind of look at it, label what I know on it. I know, okay, it appears that I've got this going on, and that's 4. There's a 5 over here. There's a 6. Now, because of the fact that the opposite, the bases are parallel and congruent, this length right here is the same as this length right here. Therefore, I also know that this is 5. In regards to the base, for surface area, I need both base area and I need perimeter. Base area, I already established, is 1/2 times the base of the triangle times the height of the triangle. And since the perpendicular is right here, it's 1/2 times a 6 and a 4, which is 12. Technically, this is an area, so it's square meters, but you don't necessarily have to put units on until the very end. To find the perimeter of the triangle, I add up all its sides, keeping in mind that when I say sides, I mean sides. That is the 5, and the 6. The 4 is not a side length of my base. And also keep in mind that the base is not always on the bottom. 5 plus 5 plus 6 happens to be 16. Once I calculate those, I have enough information to plug into this. Surface area equals 2. Base area was 12. Remember, you can use a time symbol or parentheses. I just tend to do parentheses a lot. Plus, perimeter was 16. And its height. Now, the height of the prism is the perpendicular distance that connects the bases. Going from base to base, I see this, and it appears to be perpendicular to those bases. It appears to be a right angle there, and I'm not trying to trick you on that. So that is the prism height. So 7 goes into my formula. I can type this into my calculator. I can just follow PEMDAS. It doesn't matter either way. My surface area is 136. And it's an area, so it's meters squared. Okay, moving on to our next shape. This is a rectangular prism. If it looks like a box, it's a rectangular prism. Now, when it comes to rectangular prisms, their base is really any side you call the base, but you have to be consistent in that. So I'm looking for surface area. Being a prism, surface area is 2b plus ph. Still, that's my formula. Being a rectangle, that's a parallelogram. So base area is base of rectangle times height of rectangle. Which side I do as my base? Again, it doesn't matter. I just have to be consistent. Often people look at the bottom and the top. Doesn't matter. Just make sure you know which one you chose. Let's say I do the bottom and the top. So there's the bottom. Why did it do that? Okay. Guess it doesn't like drawing this because it looks slanted. Okay. That's my base. On that base, I know that's 11. I know that's 10. So, base area. This is a rectangle. It looks a little slanted, like a parallelogram, but that's just because it's three-dimensional. 11 times 10 is my base area. That's 110. Base perimeter, I add up all the sides. Since it's a rectangle, I have some congruencies to help me out. 10 plus 11 plus 10 plus 11 is 42. So surface area is 2 times the base area plus the perimeter. Height of the prism. It's the most common thing that people have issues with. Height of a prism goes from one base to the other base perpendicularly. In this case, it's the 5. I can type it into my calculator. I can do PEMDAS, doesn't matter. I get 430. It is a surface area, so feet squared. We have one more prism showing up on this page. This is a pentagonal prism. Specifically, it's a regular pentagonal prism, which means for the pentagon, I use the regular polygon area formula, which is 1/2 ASN. Being a prism, still surface area is 2 times the base area plus the perimeter times the height. So this time, my base is the pentagon. Now, you don't have to draw it separate. I just tend to find that it makes things easier. And on that pentagon, I know this is 10. And since the other pentagon is congruent to it, I know that distance from here to here perpendicularly is 6.9. That's the apothem. S is side length, which we found to be 10. N is number of sides. It's a pentagon, so there's 5. Area equals, which specifically, I don't know why I did capital A, because remember it's because that's area's letter typically, but we want base area, so we're going to put B, 1/2 times 6.9 times 10 times 5. Which is 172.5. Perimeter of the base, I add up all the sides. The sides are all the same. They're all congruent. They're all 10, and there's 5 of them. 5 times 10, 50. So overall, when it comes to working with prisms, it's a lot of doing some of the same things. Recognizing that your height of your prism and your height of your base are not always the same. The height of the prism specifically goes from base to base perpendicularly. Calculating your base area based on what the base shape is. So you need to be able to recognize your shapes. Our surface area here is 695 kilometers squared. Here's the thing, when you're trying to find the surface area of prisms, sometimes, just like any of the others, you're going to be missing measurements, such as this one. On this one, it's a triangular prism. That's the base. Because of the fact that my bases are congruent, I do also know that there is a right angle in this corner because there's a right angle right here on the big bottom one. That's 4, that's 3. Base area for a triangular prism is 1/2 base times height. Surface area is still that same formula we've been working with. Base area on this one's easy enough because the perpendicularity here means my base and my height are interchangeably the 3 and the 4, giving me a base area of 6. But I'm missing my perimeter. Perimeter, you add up all the sides of the shape. I don't have this side, so I call it X. And sometimes I might have to use Pythagorean theorem or trig. I just focus in on finding the right triangle, which in this case, the right triangle is the entire base, so that works out nicely. Since I know two of the sides, I'm looking for the third. The third is the hypotenuse. I'm going to do Pythagorean theorem. Y'all know Pythagorean theorem well enough by now. X is 5. So I add up the 3, the 4, and the 5 because those are all sides of that triangle. I get 12. You have to be careful of that. Sometimes you're going to be missing things. It happens sometimes. Surface area, 2 times base plus perimeter times height. Height of the prism, going from base to base, is 2. Problem E is very similar. The difference on this one is you're going to have to use trig with our right triangle, and you're going to need both this length, which is either the base or the height of my triangle, and this length, that's that hypotenuse of that right triangle, in order to get the perimeter. But otherwise, same idea. When I post the notes to Schoology, I will actually have filled in this entire problem. So if you're wanting to try this problem and double check if you did it right, you're welcome to. The answer will be in the notes on Schoology. But I want to move on. I want to move on to the surface area of a right cylinder. Has to be a right cylinder. Unlike back when we were doing volume, we could have these oblique cylinders. So those cylinders that looked kind of like this, where they're kind of tipped. We can't do that for the surface area formula. It changes things completely. Surface area of a cylinder. If you were to unfold a cylinder, you would end up with 2 bases, and the sides of that cylinder, the lateral area, turns into actually a rectangle. So while we have this formula, the more common formula doesn't actually require you calculating anything before plugging things in. Since the bases of a cylinder are always circles, 2 times the base area is 2 times pi r squared, plus. Since the lateral area unfolds to create this rectangle, the height of the rectangle is the height of the cylinder, and the base of the rectangle is the circumference of the circle. So it means that the surface area formula, the lateral area piece of it, is 2 pi r h. R is the radius, h is the height, specifically of the cylinder. The radius is of the circle. So this formula is actually significantly easier to use. Like, not that the other ones were necessarily hard per se, but there is definitely a difference. So, this is a cylinder, meaning If I want the surface area formula, I'm going to do pi, oops, I forgot my 2 already. How dare I? 2 pi r squared plus 2 pi r h. So I need the radius. Radius goes from center to edge of the circle. It's 9. I need the height of the cylinder. Cylinder's height goes from circle to circle, from base to base. It's 6. So surface area equals 2 pi times 9 squared plus 2 pi times 9 times 6. Now, in all actuality, you can do an exact answer for cylinder surface area if you want. Requires simplifying everything that isn't the pi, but you gotta remember you have to have exact, you have to have integers, is what I meant to say, in front of things. But we can simplify things. This first part, the 2 times the 9 squared, would become 162 with the pi. The part here, the 2 times the 9 times the 6. Is 108 with a pi. And then those are like terms, and you could combine them. You would get 270 pi. Don't forget your units of feet squared because it's a surface area. But here's the thing. You don't have to do that. You can always just type the entire formula into your calculator all in one go. Don't forget to use the pi symbol. 2 pi times 9 squared plus 2 pi times 9 times 6. The surface area is 848.23 when rounding to the nearest hundredth feet squared. And that's what I'll more commonly expect to see, especially it's not always going to be nice whole numbers. Okay, last cylinder, and then we have to talk about similar figures a little bit. Since it is a cylinder, the surface area is still 2 pi r squared plus 2 pi r h. My radius is not given in this picture, but this is a diameter. And a diameter, remember, is a double a radius. So 48.6 equals 2r, divide by 2, and the radius is 24.3. The height of my cylinder goes from circle to circle is 8.7. So that means surface area equals 2 pi times 24.3 squared plus 2 pi times 24.3 times 8.7. This one will not get you an exact answer or anything close to it, so just type the entire thing into your calculator. You will get, sorry, I missed typing one thing into mine. 5,038.49 inches squared. The last thing we are talking about today is similar figure area. Surface area specifically. Now, the similar figure surface area, the concept of it gives you this long explanation. The ratio of the linear measures of two sides of a solid is called the scale factor, and then you square the scale factor, and that is equal to the ratio of the surface areas. But essentially what it breaks down to is it's going to be similar to what we did in chapter 11 with area. surface area of, we're going to call it shape A, divided by surface area of shape B. Is equal to a fraction of the dimensions getting divided. When I say dimensions, I mean you're just matching up some straight measurement between the shapes. It could be a radius compared to a radius. It could be a height compared to a height. It could be a slant height compared to a slant height. It could be a diameter and a diameter, a circumference and a circumference even. As long as it is something in which the units are just regular units, it works. So you can even do perimeter and perimeter. Most of the time you're going to get just a single measurement. Those dimensions, dimension of A over a dimension of B, and again, dimension is just a length of some sort, in parentheses squared. Because it is an area, the side length ratio idea that we talked about in chapter 11, in this case it's not always side lengths, hence it's dimension. That dimensional ratio has to be squared because it's an area. If it was volume, it would be cubed, but it's area. It's a surface area, so it's squared. So, find the surface area of the following similar solid. Since it's surface area, this is my setup. Fraction equals fraction. The second fraction is squared. I've got measurements of 3, 6, and 48 pi. The lengths, just the regular lengths, go in the fraction with the squared. Doesn't matter which one goes on top and which one goes on bottom. You make a choice. You make the other fraction match it. Since 3 went on top and 3 is in the same shape as this one, 48 pi goes on top. The thing you're solving for then goes on the opposite side. Remember that to square a fraction, you square the top of it and you square the bottom of it. So 3 squared and 6 squared is over here. I don't know why I wrote cubed. Squared. So 48 pi over x equals 9 over 36. And you cross multiply to solve. 48 pi times 36, well, I might as well just multiply the 48 and the 36 and leave the pi alone. I get 1,728 pi equals 9 times x is 9x. If you multiplied by the pi in your calculator, that's fine. Just round to the nearest hundredth. I'm saving myself the headache because when I divide by 9, it's going to give me a nice, easy to work with number. It's 192. Don't forget the pi. And since it's a surface area, it's centimeters squared since these measurements were in centimeters. Had you multiplied by the pi, you would have initially gotten 5,428.67 equals 9x. Divide that by 9, and you would have gotten 603.19 centimeters squared. Either of those is an acceptable answer. Sometimes they'll be nice numbers, sometimes they won't. The key thing to remember is which one gets squared. Fraction equal to fraction, it's a surface area, so the fraction squared, and it's the lengths of the sides that go in the squareds. Then you match up. Which ones were in the same shape? Put those on the same sides of the fraction. The variable goes on the other. I'm going to just go through and tell you that X is going to be 96 inches squared. If you don't see why that is, again, in the notes I post on Schoology, it'll be fully broken down. Today's homework assignment is a worksheet. So I know you've got some things written before this. Surface area of prisms and pyramid, or and cylinders. That's what we did today. Today should be the 17th. Our homework should be due on Tuesday. Tuesday's the 21st. Surface area of prisms and cylinders worksheet.